Okay, grade 11s. So today we're going to start recording the end of chapter examples. And if we look at the first example, it says the following tape was obtained from a trolley running down a smooth track at a constant acceleration, and the frequency of the timer is 50 hertz. Now remember, last year some of you had some issues with ticker timers. So if it's 50 hertz, then remember that that's the time taken. Okay, and they also tell you the time for each 2-space interval is 0,04 seconds. We're not going to focus too much on the ticker time example, but since it's in your book, I'm going to be marking it with you. Okay, so the first thing we need to do is we need to work out the average velocity for each time interval. So for A, we've got the average velocity for the interval AB. Okay, so remember, velocity is equal to displacement, and the displacement from A to B was given to us as 1,2, and I'm going to keep it at 1,2, and the time taken was 0,04. And therefore, I'm going to get my velocity to equal 30 centimeters per second. Okay, and the reason why I've done that is because I kept the 1,2 in centimeters, and I divided by the time in seconds, and that gives me centimeters per second. Okay, I'm going to move on to B, and in B, sorry, not question B, the average velocity, so let's just take that off, the average velocity for the time interval BC, and that again we take our displacement, which is 1,6, and we divide that by the time taken, which is 0,04, and for that I get 40 centimeters per second. Okay, and the last interval there is average velocity for time interval CD, and the distance there was 2, and our time interval was still 0,04, and I got an answer of 50 centimeters per second. Okay, so we're just going to go and just highlight those answers. Those were the average velocities in centimeters per second. Okay, if we go to B, B says that we need to, P is halfway through time interval AB. So I'm just going to put this on for you so you can see it if you don't have your books with you. You can see from here that they're talking about this P here. Okay, so you've got A and B, and P is halfway through A and B. You've got Q, which is halfway between B and C, and you got R, which is halfway between C and D. Okay, and what they want you to find is the instantaneous velocity. Remember, instantaneous velocity is velocity at a particular instant in time. So they want you to find the instant velocity at P, the instant velocity at Q, and the instant velocity at R. Okay, so all you need to know that instantaneous velocity, I hope you can see that, instantaneous velocity is equal to your average velocity. So if I wanted to know at P what was my instantaneous velocity, it will equal to my average velocity. So I could have said that my instantaneous velocity is 30 centimeters per second, or if I wanted to give that in meters per second, I would say it's 0,3 meters per second. So the same would go for the instant velocity at Q. It's going to equal to the average velocity at BC, which is 40 centimeters per second, or I could say, I just want to put or there, 0,4 meters per second. And then we go to average velocity at R. It's going to equal to my average velocity at CD, and that value there is equal to 50 centimeters per second, or we can say that's equal to 0,5 meters per second. Okay, so I hope you've got that. That's your memo for question 1. Okay, we're just going to stop there for a while, and I'm going to do number 2.